All right, ladies and gentlemen, what we're going to be starting off, in chapter 6. Now, this chapter has to do with special right triangles starting off. In your notes, I introduce you into two special right triangles, but before we get into this, what I want to do is I want to kind of review Pythagorean theorem. So remember Pythagorean theorem, you learned from last year in IM1. Let's say this is 3 and this is 4, and you have to find what, you got to find what this side is. Remember, it's just the shorter legs squared. 3 squared plus 4 squared equals whatever this side is squared. 3 squared is 9 plus 4 squared is 16. This equals x squared. And then when you work this down, you get 25 equals x squared. And remember, you have to square root both sides. So the square root takes care of the x, and you're left with this x equals whatever the square root of 25 is, which is a positive number. It is 5. Okay, now what they do is, in math, you're going to be using these special right triangles all the time when you get into pre-calculus and calculus and beyond. You use special right triangles all the time in math. This course is just to give you a little taste of what these triangles are. So I'm going to start off with, in the notes, I give you something called a 30, 60, 90 degree triangle. And the formula, it's not a formula, it's a pattern. This is just a pattern. It is not a formula. And you'll see why I say not a formula in a little bit. This is just a pattern. Whenever you have a right triangle and one of the angles is 30 or 60 degrees, it always works out like this. Your shorter leg is always half the size of your hypotenuse. So we're going to call this side x. Your hypotenuse is always twice this number. And your leg, your medium leg, or your taller leg, across from the 60 degrees is always the shorter leg times a root 3. Now this is a pattern. It is not a formula. And I'm going to show you why in a second. So before we get going, let's take a 30, 60, 90 degree triangle. And let's just use small numbers. Let's say this is 4. Your hypotenuse is 4. Well, the way this works is, and that's the only thing they give you, they ask you to solve for x and y. Well, this is always twice the size. Look, this is 2 times a number. This is just that number. So what number is multiplied by 2 to get to 4? The answer is 2. This is twice the size of your smaller leg. Your larger leg is this times root 3. Now, this is the way, if they give you one of these sides, these are how you find the other 2 sides. And watch, remember the Pythagorean theorem that I showed you a second ago? Well, this actually works for this. It works for any kind of right triangle as long as everything's labeled correctly. Watch, I'm going to do it. You don't need to do this, but I'm just going to show you. 2 squared plus, or a squared plus b squared, which is 2 root 3. This is a, this is b. This equals c squared. Remember, a squared plus b squared equals c squared. Now watch, mathematically it works out. 2 squared is 4. 2 root 3 twice, this means 2 root 3 times 2 root 3. So 2 times 2 is 4. Root 3 times root 3 is the square root of 9. And what is the square root of 9? 3. You should have learned how to multiply numbers and roots last year in IM1. 4 times 3 is 12. Once again, or you could just do this, square the 2 to get 4. When you square a root, it cancels out the root and you're left with just a number inside. So 4 times 3 is 12, no matter how you do it. This was from last year, that's why I went over it kind of quickly. Equals 4 squared, which is 16. 4 plus 12 does equal 16. It works out. Pythagorean theorem will always work out as long as these are done correctly. Now, in the notes, I give you a couple example problems. And the example problems that I give you Start off with an easy one. I give you a right triangle of 8 root 3, and I tell you this is at 30 degrees, and this is 90. So by default, this has to be 60. What would this side be? Well, look at the pattern. Not a formula, just a pattern. You'll see why I'm saying it's not a formula in a second. This side is always your small side times root 3. So this is 8 because 8 times root 3 is 8 root 3. So whenever you're given the side across from the 60, the shorter leg is just this number. And then your hypotenuse is twice that, which is 16. All right, next one. I give you a hypotenuse of 10. Pause this video for a second and see if you can actually find what the other two sides are. Pause the video, see if you can find this side and this side. All right, so if you paused it, you should have understood that your hypotenuse is always twice the size of your smaller leg, and your larger leg is your small leg times root 3. Super simple. You don't need to do this, but if you wanted to do the to do Pythagorean theorem, a squared plus b squared would equal c squared. Okay, now this next one, the third example, if you look on the notes that you should have printed up in front of you, you should see this goes into a little shortcut, which I'm going to talk to you about in a second. But let's start off with this. Let's just start off with this triangle. 60 degrees, this is 30 degrees, and this is 90 degrees. Now, I tell you this side's 21. Well, remember I told you this is not a formula. It is a pattern. The reason why it's not a formula is because normally people say, well, wait, in the formula, there's a root 3 in it. But there's no root 3, so this can't be wrong. The formula doesn't work out. It's not a formula. It's a pattern. This is when it gets tricky. This is the only real time for Math 2, just for this course. These get really in-depth. But it's the only time for this course when this is going to actually get tricky, when the side that they give you normally has a root 3 next to it, but now they multiplied that root 3 into it. What you have to do is you have to pull out that root 3. Now, I'm going to walk you through a Mathanese kind of explanation. If you don't understand this, we're going to go on to this shortcut to figure out what these two sides are. But let me explain this conceptually for you. This side, which is normally x root 3, I'm just going to write it. This side's normally x root 3, but see how it equals 21 now? Here's my actual equation to solve. Look, this side is x, and this is twice that. Okay, well, I have to divide both sides by root 3 because I'm trying to solve for my x. So I get x equals 21 over root 3. But mathematically, I cannot have a root 3, or square root is your denominator. So conceptually, you have to multiply the top side and the bottom side by a special form of 1. Because look, root 3 over root 3 is 1. And you can multiply any fraction by 1 to still get the same value. Why am I multiplying it by root 3? Because I need to get rid of my denominator as a square root. Watch what happens when I multiply the bottom by root 3. Root 3 times root 3, the square roots cancel out, and you're just left with what's inside, 3. Because square root of 3 times square root of 3 is the square root of 9. The square root of 9 is 3. But you have to multiply the top by root 3 also. So 21 times root 3. And here's my unsimplified answer for x. See how it says x equals? What is x? It's this side right here. But look, 21 divided by 3 is 7 with that root 3. If I lost you, rewind this video and just go step by step over what I just did again. Now look, this is 7 root 3. This side is always twice that. So 2 times 7 is 14 root 3. Now, I just found all 3 sides. And if you look on the notes, what I tell you is this. If this example didn't make sense of how I mathematically obtained this answer, a lot of people don't, in math 2, they're not mentally thinking like conceptually how this works out. So what I always tell people, if I lost you getting here, just think of it like this. Just think of this shortcut. Whenever they give you in a 30, 60, 90 degrees triangle, a side across from the 60 is an actual number, not a root, but an actual number in it. Divide this number by 3 and put a root 3 next to it. That's what your short leg is. And then multiply this number by 2, and that's what your hypotenuse is. Once again, if they give you this as a number, as they give it to you as x, this is this number divided by 3 with a root 3 next to it. Always works out like this. And then your hypotenuse is this number times 2. So you just multiply this outside number by 2 with that root 3. And those are 30, 60, 90 degree triangles. Okay, the next kind of special right triangle that there is something called a 45, 45, 90 degree triangle, or more commonly known as isosceles right triangles. Why are they called isosceles and not 45, 45, 90? Because if you have an isosceles right triangle, the sides are congruent, the base angles are congruent. So by default, each one of these would have to be 45 degrees. Now I give you 2 ways that they're set up. And these are pretty simple. If they give you both of the sides as a number, your hypotenuse is that number times root 2. For example, let's look at the first one that I do. I say you have an isosceles right triangle and this side is 5. If this side's 5, this is an isosceles triangle, so they're the same. And this is 5 root 2. That's the pattern. It's not a formula, it's just a pattern. Watch, let's do that. Let's prove this to see if it's actually true. A squared, you don't have to prove this, plus b squared, but I'm just showing you that everything works out, equals c squared, which is 5 root 2 squared. Now look, 5 squared is 25. 5 squared is 25. Does this equal 50? Because 25 plus 25 is 50. This is actually 50, and I'll show you why. If you square the 5, you get 25. If you square the root cancels out, and you just get the number left inside. This is 5 times this. So 25 times 2 is 50. This checks out. I'm going to give you a question to try that's not in the notes. But let's see if you can do this before I give you one more. Let's say you have a square. You know that a square at every single side is the same. And every side is a right triangle. What I'm going to ask you is this. Let's take a square. Let's say the perimeter is equal to 28. What's the length of this diagonal? If this is a square, the perimeter is 28. What's the length of this diagonal? Pause the video and see if you can do it. All right, well, if you paused it, look, the perimeter is 28. Every one of these sides are the same. So what number added 4 times gives you 28? 7. Okay. The question is, what is the length of this diagonal? What is the length of that diagonal? Well, watch this. If I get rid of everything and I just leave this as a 45, 45, 90 degree triangle, look, it's very easy. 7, 7, the length of this is 7 root 2. Super simple. Okay, now the next one. Look at the next formula, or look at the next pattern that I give you. I tell you that you have an isosceles right triangle, but there's a difference now. Notice the hypotenuse is a number. These two sides have the root 2 now. So look, if your hypotenuse is a number, each one of these is half of this number with the root 2. It might look kind of confusing until I actually put it into actual numbers. So let's say this side is 10. Well, this side would be half of 10 root 2. Look at the difference between these two examples. If you use Pythagorean theorem, this will work. If you use Pythagorean theorem, this will work. A lot of students ask, how do I know which one I do? Well, it depends on where the whole number is and where the root is. Notice in your hypotenuse in this one, they gave you the root 2 inside here. That means each one of these is just this number. If they give you your hypotenuse as a number, then each one of these follows the other one, where it's half of it root 2, half of this root 2. So look at the second example. The second example says, all right, this is 14. What is this side? Is this type of triangle or this type of triangle? Hopefully you understand that it is this type of triangle. So therefore, if they give you your hypotenuse as a number, remember, here's a number. Half of the hypotenuse is 7 with a root 2. 7 with a root 2. Now do the Pythagorean theorem for any one of these triangles and it will work out.